Good morning to all. I am Dr.S.V.Mahesh Kumar, Associate Professor, Department of ECE, Bharat Institute of Higher Education and Research. In the earlier classes, we discussed about various design parameters and design process of embedded systems. In this session, we will going to discuss about real-time operating systems used in embedded systems. These are the contents of my presentation. We start the session from real-time task. What is real-time task? And then examples of the systems with real-time task. Then types of real-time task and what is RTOS, real-time operating system, and what are the kernels used in real-time operating systems, and then real-time scheduling algorithms used, online scheduling, and then offline scheduling algorithms, and then dynamic priority, and then rate monotonic algorithm, and earliest deadline first algorithm. Finally, we conclude the session with qualities of a good real-time operating system. This is the reference for this session. So first we start from what is a real-time task. A real-time task is a task in which the performance is judged on the basis of time. So if a task is completed with a specific time means, then only it is considered as a real-time task. So the result of a computation is correct only if it has produced this correct output within the specified time. So time is the key phenomenon for a real-time task. So a task could be completed correctly within a specific time only, it will be considered as a real-time task. So these are the examples of systems which are using real-time tasks. So first one, process control in industrial plants. So the industrial process is completely related with the time period only. So each process, it is many sequential processes are there. So output of the second process is depending the input of the second process is depending the output of the first process. Similarly, the input of the third process is depending the output of the second process. Similarly, it's a sequential process. So each task should be completed within a specific time. Then only the sequential process can be done effectively. So process control systems are highly related with the time. So real-time tasks are used in process control systems. Second one, robotics. So robotics also, we are using many sensors and then we are controlling many sensors and we are producing the output according to the inputs we are receiving from the sensor. So this is also a real-time task only. Then traffic control. So each signal is enabled and disabled with respect to time only. So this is also a real-time task is used. And then telecommunication, synchronization is very essential for telecommunication application. So we are preferring a real-time task in telecommunication application. And then weapon guidance systems. These are also, it is a challenging task and as well as it is related with quick decisions also. So we are using a real-time task in weapon guidance systems. Medical diagnostic and life support systems also related with time period. So every task should be completed within a fixed time, otherwise it is useless. So we go for a real-time task and real-time operating system. Then only you can provide a output within a specific time and we can manage the systems effectively. Then automobile engine control systems, anti-lock braking systems, and real-time database access are the systems which require a real-time task. So what are the types of real-time tasks? The first one, hard real-time task. The hard real-time definition considers any missed deadline to be a system failure. If a process does not complete it within the deadline means that is considered as a failure task and that is considered as a system failure. The scheduling is used extensively in mission critical systems. mission-critical systems are using this, the failure and time constraints results in a loss of life or property, because it is related with a real-time task, and then if the task is not finished within the deadline, then it will loss of life, it will create loss of life or property. Due to this reason, it is called as a hard real-time task. Example, it's an Air France flight 447 crashed into the ocean after a sensor malfunction caused a serious system errors. So it made some errors are happening with respect to the sensor malfunction. The pilots stalled the aircraft while responding to outdated instrument readings. So the system is responded with respect to the outdated instrument readings. So it caused a life loss. So it is known as a hard real-time task. And soft real-time task is the other category of a real-time task. The soft real-time is definition allows for frequently missed deadlines. So it is related with the frequently missed deadlines, and as long as tasks are timely executed, their results continue to have a value. So if the completed task may have increasing value up to the deadline and decreasing value positive. So compared with the previous case, in the previous case, we are considering only if the task is finished within the deadline itself. Here we are considering whether it is finished within the deadline or other than the deadline. If it is finished before the deadline, means it will be increasing value up, and if it is finished after the deadline, means that it is a decreasing value up. Example, a weather stations. Weather stations are the best example. Weather stations have many sensors for reading temperature, humidity, wind speed, etc. The reading should be taken and transmitted at regular intervals. However, the sensors are not synchronized. Even though a sensor reading may be early or late compared with the others, it can still be relevant as long as it is close enough. So we can get the inputs, we can accept the outputs within a deadline, or even it crosses the deadline, then it would be known as a soft real-time task. Compared with your previous hard real-time task, it is allow the input after the deadline also. Only the difference is it decreasing the value if it is crosses the deadline. If it is finished within the deadline, means it provide an increasing value of. This is the major difference between a previous case hard real-time task and a soft real-time task. Firm real-time. The firm real-time definition allows for infrequently missed deadlines. In the previous case, it is frequently missed deadlines. Here it is infrequently missed deadlines. In these applications, the system can survive task failures so long as they are adequately spaced. However, the value of the task completion drops to 0 or becomes impossible. Example, a digital capable set-top box. It decodes timestamps for when frames must appear on the screen. Since the frames are a time order sensitive, a missed deadline causes jitter. If you are receiving a time frame, your timestamps continuously. If it is a missed deadline, means it causes a jitter and it will reduces the quality. So if the missed frame, after that we are receiving the missed frame later, becomes also causes a jitter, more jitters on the display, so it is useless. So compared with the previous case, it is infrequently missed deadlines. Then periodic tasks is the next category, periodicity. So periodic tasks are real-time tasks which are activated or released regularly at a fixed period. So here the periodic means it repeated after a fundamental period, or every time it is repeated after a fundamental period. Here we can see a task, or yes, task T is there. This is the time period T1. The task R is there. After that, we can get the same task at T2, T3, T4. So this is the period. So the same task is repeated. 1, 2, 3, 4. So these are the real-time task activated at every time period. See, it is activated, activated. So every time period it is activated. With respect to time, it is periodic. So this kind of tasks are called as periodic tasks. What is the example? Consider a number of sensors in a chemical plant. It is an example for that. These sensor inputs are sampled at regular intervals, which are fixed period. So this is known as a sampling period. The samples are this sensor, the output from the sensors are sampled at a particular time period. That is known as a sampling period. So this kind of task is known as a periodic task. Every time period, after every time period, it is repeated. Next, aperiodic. Compared with the periodic, aperiodic means it won't repeat it after a fundamental period. We cannot find any fundamental period for that. That is known as aperiodic. An aperiodic task is a stream of jobs arriving at irregular intervals. The periodic, it is a regular intervals. Here it is a irregular intervals. The process cannot be repeated after a regular interval means that is known as aperiodic task. The definition of aperiodic task indicates that the time interval is not a same. So inter-arrival period between two tasks can be 0, which means that two aperiodic tasks can arrive at the same time also. This is the way it is different from a periodic task. So it can be the time interval is not a periodic one. Here we can see the time period is not a periodic one. The time between here you can see it is not same with respect to this one. Here it is more, it is less. In the previous case, it is same. The time interval is same. Here the time period is irregular. So this is known as aperiodic. What is the meaning of that? Means the same task is not repeated or the same task is not activated after the same time period. So the time period is irregular. What is the example for that is an operator's command from the surveillance system, like radar or other things is the example. Along with the processing the surveillance signals, it cannot be repeated after a fundamental period, or it cannot be repeated within a specific time interval. We can receive the signal at any time interval. So the time interval is irregular, so it is known as aperiodic task. Sporadic task is another kind of real-time task. A sporadic task is an aperiodic task with a hard deadline. This is the difference. It is an aperiodic task with a hard deadline and minimum inter-arrival time between two tasks. For example, emergency conditions like overspeed of critical machinery in a plant. It cannot be erased every time. It is a aperiodic task. It can be erased at any time. We cannot expect a overspeed for a particular time interval. It can be erased at any time. So this is aperiodic, but the deadline is hardest one. We should finish it immediately within a less time accessing time. We need to solve the issue within a particular time. So the deadline is hard, but the task is aperiodic. Then it is known as sporadic task. And another one, preemptable and non-preemptable task. This is the other category of task, real-time task. So preemptable and non-preemptable. In some real-time scheduling algorithms, a task can be preemptable if another task of higher priority becomes ready. So it is depending upon the other higher priority task. So preemptable is depending upon other higher priority task. The execution of a non-preemptive task should be without interruption once started. So it's a difference. Preemptive means it can be wait for the other high priority task, and the execution is purely depending upon the arrival of other higher priority task. In non-preemptive task, it should be executed without any interruption. Once it is started, it should be finished. You can see the task here. Here you can see the task, and then the task 1 is there, and then task 2 is there. Within this period, the task 2 is executed, and then your T1 is executed, and it executed completely. It doesn't depend upon this T2. Here it's depending upon the T2, and only the period is empty within this the period of T2. So this is a difference between the preemptive and then non-preemptive tasks. So RTOS, real-time operating systems. We discussed about various real-time tasks. So we need a system, we need an operating system to solve and to proceed this real-time task. For that purpose, we are using a real-time operating system. So what is the purpose? What it actually provides means the RTOS provides an abstraction layer between the embedded hardware and the application software. In our previous sessions, we discussed about what is the relation between an application software and a hardware. In an embedded system, an application software is loaded in a hardware, then only it is dedicated to solve a practical issue, then only it can be used for a particular application. So the RTOS provide an abstraction layer, real-time operating systems provide an abstraction layer between the embedded hardware and this application software. And what is the role? The RTOS ensure that the multiple tasks that comes in are managed and done on time. So every task should be completed within a specific period. The RTOS assure that it should be completed within a simulated deadline. So this is the major function of real-time operating system. And why it is necessary, why we are using this RTOS means RTOS is necessity in complex embedded real-time system which dealing with many tasks which should be completed within the deadlines. So we can see in the diagram, the RTOS you can see here. This is the application software and then hardware. So it provides an abstraction layer between this application software as well as a hardware. So RTOS kernel. So RTOS has a kernel which form the core of the OS. You can see the kernel. What is the major role of this kernel is a task management is a key factor for this RTOS, because RTOS handling many tasks which should be completed within a stipulated period. So we should concentrate about RTOS time management. So here kernel provides this time management. It deals with the time management. You can see here, this is the task management is there. What are things is there? Inter-task communication and synchronization. So real-time system handle more than one task, and then tasks are related with each other also. So you should complete the task, the system should complete the task within a deadline. So the time management, real-time management is the essential one. So inter-task communication and synchronization is performed by this task management, and then it deals with various timers which is used to access what is the time period, what is the time delay related with the operation. So and then device IO supervisor, what are the inputs and output devices are used within this time task, and then within this time period what are the devices are accessed, whether there is any simultaneous access are there. Everything should be managed by this RTOS. And finally, this dynamic memory allocation is also a role of our RTOS kernel. We need to design, we need to allocate a memory according to the task. So which tasks requires this memory management, what is the data memory required, everything is decided based on this task management feature of RTOS. These are the algorithms. We are using many real-time scheduling algorithms related with RTOS. So these real-time scheduling algorithms can be classified into two types, offline and online. So online systems are related with online scheduling algorithms are related further classified into static priority and then dynamic priority. And then static algorithms are again classified as preemptive and then non-preemptive algorithms. And then dynamic priority algorithms are classified as planning based and best effort. So this online scheduling algorithms deals with all these properties: static priority, dynamic priority, and then preemptive, non-preemptive, planning-based, and best effort. We are considering so many parameters with respect to this online scheduling algorithms because it is real time. It is updated means we should concentrate about the priority also, whether what are the priority, and then we are concentrated about the preemptive status and then effort status also. This is a off time scheduling algorithm. We discussed about this off time scheduling. So off time, online, both are related with the time. So it's a pre-runtime scheduling. They generate scheduling information prior to system execution. So what are the thing is the scheduling information and what is the time required to execute the task. Everything should be decided prior to system execution. Before executing this algorithms, you should know about, before executing this various tasks, you should know about what is the time period required for a particular task, what is the time deadline of the task. Everything should be updated before. Everything will be scheduled before execution. That is the main thing. The scheduling is based on the knowledge of the release times, deadlines, and execution times of all the tasks in the system. So what is the thing is you should concentrate about deadlines of all the tasks in the system. So you should know the knowledge of about the execution time of various tasks before system execution. That is important. This is the deterministic system model. The exact timing of the tasks are known prior. This is the very key factor of this off-time scheduling because this is a pre-runtime scheduling. So you should know the exact timing. You should know the exact timing of the task prior. The scheduling algorithm can produce a precise schedule which optimizes one of several different measures of, and optimal algorithms can be used which can guarantee very good system performance because we know the time required to execute, we know the deadlines of every task, so we can schedule according to the deadlines, then only we can achieve a good system performance. And this is the optimized performance because we are handling many tasks, but we know the execution time and the deadlines of the task. So we can arrange, we can schedule according to the deadlines, so we can achieve a good system performance. What the application means? It is suitable for factory settings, fixed factory settings, because we are using a same kind of task day to day. So the tasks won't be changed. So we know what is the time required to complete the task, what is the deadline, everything we know prior. So we can implement this off-time scheduling algorithm for these factories, which doesn't require frequent updates because the system is stable. We are repeating the same process. We are repeating the same task day by day. So first schedule we are finishing. What are the things are there? What are the tasks are there? What is the time deadline is there? So we fix the task according to the deadline, and we form a model according to that deadline. So it can remains same for other executions also. So these kind of systems, fixed factory settings, can use this off-time scheduling algorithm. Online scheduling. This also related with the time. Static, two priorities are there. The static priority. Higher priority gets the chance to execute first. The task with higher priority can be executed first. That is known as a static priority. It is one of the most popular of the scheduling methods. The method can be preemptive or non-preemptive. In non-preemptive scheduling, the task with the highest priority is run until it is completed. This is the key factor because the task has a higher priority. So the system should finish the task first. So it is executed continuously until it is completed. Then preemptive priority-based execution. Execution of any task can be preempted if a task of higher priority becomes ready. So it is purely depending upon the task of higher priority becomes ready. Then all times the processor is either idle or executing the ready task with the highest priority. So it is purely depending upon the task, ready task with the highest priority only. Dynamic priority. Dynamic priority to be changed at runtime. the priority should be changed with respect to runtime. Scheduling requires more computation, because what is the thing is, the schedule priority is changed within runtime itself, so the scheduling requires more computational process. And then preemption may or may not be used. We discussed about the preemptive process. It may be used or may not be used in the dynamic priority systems. The flexibility is quite high in these systems which adopt this method, because the priority is changed with respect to runtime itself. So it is, we can change the priority within the runtime itself. So it is a compatibility adaptable systems. Two subsets are used in this dynamic priority system. First one is a planning based techniques. It guarantees deadlines for all the accepted tasks. So it should complete all the accepted tasks. So this is known as a planning based technique. And the best effort system guarantee the deadline of all the hard real time tasks, because a hard real time task should be finished within the deadline. Otherwise, many failures or lifetime related issues are there. So it should be solved within the deadline. Your best effort systems guarantee the deadline of a hard real time task while optimizing the performance of soft tasks. So it deals with a hard real time task, a more priority, and then which optimizing the priority of performance of a soft task in the second category. So this is the difference between the planning based and then best effort algorithm. Planning based techniques guarantee the deadline for all tasks. Your best effort algorithm guarantee the deadline for the hard real time task. Rate monotonic algorithm. What is the term rate monotonic derives from a method of assigning priority to a set of processes. You are assigning what are the priorities to a set of process. Assigning priorities as a monotonic function of the rate of periodic process. The term monotonic means either increasing or decreasing of a set of values. You can see the conditions in this equation. This is a monotonic increasing or decreasing of certain values. You can see here the LHS of inequality is related to the total CPU utilization for n task. CI is the execution time, which is also known as CPU burst here, and PI is the period of task. So the CI and PI. What is the execution time, CPU burst time, and then what is the period of task? So it gives the information about both things. What is the period is required to complete the task, and what is the CPU burst time period. So if the condition is satisfied, means the RM algorithm will be able to schedule the task within their respective deadlines. So n is the total number of tasks is there. So it is related with, it should be less than or equal to summation of I is equal to 1 to n Ci bar Pi. So it totally depending upon a CPU burst and time required for a particular task. So this is the condition they are using in rate monotonic. This is the sufficient condition, but it is not a mandatory condition. So because we need to provide better solutions, we need to provide a deadline based solution. So this is the condition for that. We can explain the rate monotonic algorithm with the help of an example. Consider two tasks, T1 and T2. Here T1 is there and T2 is there. The time period required for this 12, for T1 12, and CPU burst is 5. We already discussed about the equation. In the previous slide we discussed one equation. According to the equation, that is depending upon two things. One is period of the task and then CPU burst. So for T1 the period is 12 and then CPU burst is 5. For task 2 the period is 7 and CPU burst is 3. What is the condition is, a task with minimum period should be executed first. Here T1 is the time period required is 12. For T2 is 7. So minimum time period required is T2. So we should execute task 2 first. Here task 2 first. What is the CPU burst for T2? It is 3. So 0 to 3. And then again, this task is executed from 7 to 10. So 3 CPU bursts is there. So task 2 should be completed within the time period 0 to 3, and then 7 to 10, like that. And we should execute the task with minimum time period first. So I execute T2 first before T1. T2 is executed because T1 requires the time period of 12. So T1 is executed after T1, after T2. T1 is executed after T1 because the time period is more compared with the time period of T2, which is 7. Earliest deadline first algorithm is the other category. It also belongs to the class of dynamic priority allocation method. Priority of tasks can change at runtime itself. That is the reason this is known as a dynamic priority. So the priority of task can be changes at runtime itself. At any instance, the highest priority task is one that has the closest deadline. So we are deciding the highest priority task based on a closest deadline only. Tasks that cannot be scheduled by the RM algorithm because of high CPU utilization can be scheduled by this method. So the CPU utilization is high in RM algorithm. If we cannot solve the issue in the RM algorithm, means we can use this earliest deadline first algorithm. This can be used to solve the scheduled tasks, and then it can be changed with respect to the priority, and then priority can be changed runtime itself. So these are the key parameters of this earliest deadline algorithm. You can see example for earliest deadline algorithm. In the previous case, we start with a 2 task. Here we start with 3 tasks, T1, T2, and T3. 3 tasks are there, and the period for T1 is 4, and the CPU burst is 1. For T2, the period is 6 and CPU burst is 2. For T3, the period is 9 and CPU burst is 4. So various tasks are there. The time period is different for each task. For T1, the period is less. Earlier slide we discussed about that. The task with minimum time period can be executed. So first T1 is executed first. After that T2, and then after that T3. What is the condition is every task should be completed within the deadline itself. So the deadline for the first task is 4. So T1 is completed within 4. Here T2 is completed within 6. It executes a 2 burst. So 1, 2. T1 is solved within 1 burst. So 1, 2. What about T3? T3 is 4. The 4 CPU burst must be completed within the period of 9. Here it is completed after 9. So this is known as missed deadline. Again, I summarize this one. T1, T2, T3. T tasks are there. For T1, the time period is 4, CPU burst is 1. For T2, the time period is 6, CPU burst is 2. T3, time period is 9, CPU burst is 4. A task should be completed within the deadline. This is the condition. And a task with minimum time period can be executed first. So here, comparing these 3 tasks, the time period 4 is the lesser one. So least one. So the least one is T1. So T1 executed first. After that T2 executed second one. T3 third. CPU bus for this one is T1 is 1. So 1. CPU bus for T2 is 2. So it requires 2 within this 2. And then third one is 4 and the time period is 9. So it processes above 9. So this is known as missed deadline. So let us conclude the session. We discussed about various real-time tasks and why a system is required to solve a real-time task and what is the role of RTOS, real-time operating systems, required to solve, and how the RTOS solves various tasks with respect to time. So what are the qualities of a good real-time operating system? First one, performance. Okay, it must be faster and it gives a high throughput. That is the first one. So it should be faster. At the same time, it should be complete the task within this effectively. Then only it is considered. And then reliability. The system should be provide the results with respect to various time periods. So this should be reliable. And then compactness is the factor. So it should be occupy a very less memory, because we cannot spend a more memory for operating systems. There should be occupy a less memory than only the real-time system, because we are using a compact devices which has a very less memory. If the operating system itself occupy more memory, means it's the challenging one. So a operating system should be occupy less memory, then only a compactness is achieved. So we prefer operating systems with less memory, and scalability also. The good autos solve the scalability also. So because many operating systems are large to many type of application, it is necessary to that we are using applications which should be a scaled down. So this is also important factors of a RTOS. So based on these qualities, we are choosing the RTOS for our embedded system. Thank you.